Hey everyone, welcome back. In this video, I want to talk about the domain and the range. And let's go ahead and get started by defining exactly what these concepts are. So when we use the term domain, we're usually referring to the domain of a function. And what the domain of a function is the set of all inputs for that function. On the other hand, we also have the range, and that is going to be the set of all outputs for a function. So remember, when working with a function, we usually have an independent and a dependent variable. The independent variable we think of as the input, and that is usually represented by the variable x. And then we have the output variable, or the dependent variable, and that is usually y. So another nice way to think about the domain and range is if we're working with a function like y is a function of x, then the domain of that function is going to be the set of all x values. And the range of that function is going to be the set of all y values. So we've seen that our functions can be represented in lots of different ways, sometimes a graph, sometimes an equation, or even a table. And no matter how our function is presented to us, we want to be able to find the domain and range for that function. Knowing things like the domain and range are useful when we want to graph the function by hand, and they can also be helpful when working with applications. If we get an answer that doesn't make sense, we'll often want to compare our answers to the values we find in the domain and range to help us make sure that our answer makes sense given a context. So now let's go ahead and look at some examples of functions in some different forms and try to identify the range and the domain from the function. So let's go ahead and get started with the domain of the function, or the set of all inputs, or the x values that our function goes through. And all we have to do to find the domain of the function from the graph is look at the graph and all the points that are included on the graph, and look at what x values are included in all of those points. And so if we look at our graph, we can see the smallest x value that we actually get close to but don't actually hit is the x value of +1. And the farthest right x value we obtain occurs at the x value of 4. And we have to also make sure that we have all the x values in between those two x values as well. So the domain of this function are all the x values that are strictly bigger than 1, right? That open circle means we cannot actually include that x value of 1, and we can go as far to the right as we want until we get up to x equals 4, and there we actually can hit or include x equals 4. And so now when we want to describe our domain, we usually do it in one of two ways, and that's using that interval notation or that inequality notation, and that preference is usually up to you. So let's go ahead and do it both ways for this example just to get some practice in. Let's go ahead and start with inequality notation. So we're describing the domain. That's some x values. On the left is the smallest x value we hit, and on the right is going to be the largest x value we hit, or at least get close to. And as we discussed earlier, the smallest x value we can get close to but not actually obtain is the x value of +1. So we have to use a non-inclusive inequality sign there. Here this is saying that x is greater than 1, or that 1 is less than x. And we also know that x can go up to +4 and also include +4. So the domain of this function is going to be the set of x values that are strictly bigger than 1 and are less than or equal to 4. So we can describe it in one interval here using a single compound inequality. Right? Our other option, and we don't have to include both ways, just one of these forms. The other option for describing our domain is using that interval notation. And so here on the left-hand side of our interval, we'll have an open interval because we cannot obtain that leftmost x value of 1. And then we can keep moving to the right until we get up to x equals 4. And remember, we can include x equals 4, so we have to indicate that in our interval notation, and that is done with a square bracket. So we've wrapped up the domain, we've described the domain from the graph of this function. Now let's go ahead and try to do the same, but for the range. And so now all we have to remember for the range is we're not looking at the x values anymore, but the y values or the outputs. And so now we're going to kind of scan the graph here, but kind of pay attention to the y-axis and those y values instead of the x-axis and the x values. So let's see, the lowest y value that we get close to but actually don't hit is going to be y equals -1. And the largest y value we get up to is y equals +4. And there we include that highest y value, but we exclude that lowest y value. So again, we have a similar shaped interval, open on the left-hand side, and closed on the right-hand side. So this is our description for the range using inequality notation. And if we wanted to convert that to interval notation, it would just look like the interval from -1 to 4 that is open on the left-hand side and closed on the right-hand side. Describing the domain and range from the graph of a function is a pretty straightforward process. The only kind of tricky things we have to watch out for is if we have like a vertical asymptote or something that is causing a discontinuity, then we might have multiple intervals for our domain and or range.